And five holes. Can start. Go. You drive in the hood, 15 millimeters per minute now.
Welche Distanz hast du angegeben?
Hier training.
You can go ahead and start, Enrique, if you want to.
Yep, already did. Start that time.
Bei euch alles gut? Yes, good.
Allow 60 liters. Up to 404. Yeah, now 88 millimeters. From start process, let it come through up in the sound. So
Okay, this was the final hole. So we can proceed, right?
Okay. I would now go ahead and start the.
we're now in the final phase. Now it's the team to together.
So if you would have everybody mute their phones except for this one camera, so that we don't get much feedback. And you've got your pilot hole drilled apparently. Is that correct?
Okay, let's go.
You want to proceed, go ahead.
Yeah. We have a little bit of struggle. Okay. Problem. How many Fetters noch manuell hoch? Der Motor reagiert.
24 Volt.
Warte,
Aber check das die.
Der Teil ist auf 0. Okay, ich mache die Motoren wieder, ich mache die Power Supply wieder an. Die pumpen nicht, dann fährst du hoch, ja? Ja. Drück den Knopf. Go. Okay, yeah, we made the pipe, but okay, we're in the hole. Hopefully,
Was machst du denn da? Einfach mal langsam.
I'm yeah. Hard. Okay. Okay. Now again. Warum?
Sag mal ganz stopp. Ich muss das die Pipe erstmal.
Warte.
Eins nach dem anderen.
Jetzt kannst du. Okay. Ich mach den Strom aus, dann kannst du einmal die Pipe beenden. Okay, ich take the current off. Was ist das jetzt hier? Nein, der ist. Noch laut? Sorry. Anlage ist jetzt aus. Wir können den Hauptschalter ziehen und dann kannst du die Pipe einmal gerade biegen.
Also müssen wir eine Abdeckung? Okay. Nee,
Die sind der Motor. Also wir können es jetzt noch mal probieren. Ich gucken, dass das
vielleicht ist es weniger
ja, aber am Setboard lag der Motor war gar nicht an.
Tell us what's going on.
So the motor was not responding and it didn't turn on and the Z-axis drove through. We now turned off the machine, we bent the pipe straight again. We will do a second approach and we'll see how this goes. But
Okay.
yeah, okay. So we'll start again.
Motor wird an, Maschine an.
Servers aus. Okay. For the initiation. Yeah. Initiation. You want to do that?
Also einfach nochmal von vorne. Ne?
Ja.
Am besten auch mit Nullen oder was?
Yeah, we have to do the rock zero again. Okay, we're homing now. Wait a minute, that I won't go on. Okay. Guys, it's serious. Läuft da Internet, ne? Jetzt sind die getragen. Aufziehen, auf das. Ja, okay. Ich würde sagen, wir machen jetzt mal den Short und lenken mal.
Die Flügel sind ausgefahren?
Lenken mal uns.
Ja, die Flügel sind ausgefahren.
Ja, guys, ich habe keine Command reingebunden. Also wir haben eine Survey, haben wir angefangen gehabt, damals aus dem Motor stehen geblieben. Dann ist er nicht nochmal angegangen. Aber okay. Einfach zum anderen. Wer hat was?
Mach erstmal die Flügel rein.
So, ich war erstmal den Rotary Table wieder auf 0. Ne?
Hier die Flügel erstmal Flügel rein.
Homing.
Ja, weiter.
Ist okay, die drücken dann von alleine. Okay. Ich drehe den Rotary Table kurz wieder gerade. Power ist off, ja.
Du hast die alte verloren.
Ich drehe die wieder hin. Ich muss sicherstellen, dass wir jetzt hier nichts.
Damit die einen verloren.
Etwas? Erstmal? Okay.
Normal.
Läuft der Broker noch? Ja? Okay. Ist der Ruf ausgebrüht oder irgendwas? Hauptschalter? Okay, das ist neu. Jetzt wird es morgen. Okay. Haben Sie jetzt aber auch nochmal an.
Also die Maschine auf.
So ist es. Ja, Jungs, fahren wir heute mal Rhythmus oder fahren wir nach der Vorschule und legen die Flügel über den Klettern?
Ich würde sagen, wir haben sehr gute Erfahrung mit gesamten Vorschub.
Ja,
Weil wir sollten verhindern, dass die Pipes sich wieder biegen.
Dann verlieren wir
Ja?
das Ding.
nee, schon, wir machen das jetzt irgendwie zu implementieren schnell, weil eigentlich konvertiere ich das den Controller. Ich kommentiere den Controller alles aus.
Aber nicht gleich.
Jetzt mal hier.
Genau, Controller, also ich mache das für Flash.
Nee, das ist mit Ding.
Und
Ja,
das
wir brauchen
aber nicht. Machen wir jetzt erklärt man das. Nein, du machst das jetzt. Du machst das jetzt. Wir bohren jetzt dann mit jeweils 100 Schritten und wie viel Beat? Haben wir gerade gemacht.
Aber der Gäste hat den Server auf seine Rechnung gehabt.
Ja, ist egal. Also jetzt kommen wir direkt ins Programm, wir fahren 100 Schritte, jedes Mal im Lauf mit 50 Speed. 100 Millimeter, ja, viele Millimeter. Und
Dann ist jetzt automatisch.
Dann nicht.
das
Hey, Fred, so the tuck team is gonna have to reset their server. So what we'll do is we'll switch over and have the UMONs team go through their process and
Okay.
give you guys a little bit of time to get it sorted.
Sounds good.
Ready?
Perfect.
das macht keinen Sinn, weil
Was mit dem Server? Die Kandidaten rein. Jetzt kommt wieder, ne? Okay. Ja, kann das jetzt raus?
Ich auf Minute
Okay. Yep.
Wie hat er ausgestellt?
If you have any, just kind of walk the team online through what you're doing there.
Das heißt,
As you get started and get everything going, explain to the judges that are online to kind of what.
das war die erste.
Like through what.
So, if you can hear me, I will begin the drilling process for UMONs team. So, first we are going to begin. We will begin to engage the pump, engage the rotation speed, and at low speed, and to let the bit enter in the pre-hole that we made. The pre-hole is about 20 millimeters deep. When when the bit is well entered in the pre-hole, we will increase the rotation speed manually, and then we will let the regulation loop control the drilling process until we get until we hit the targets that you just sent to me by email. So, well, can you say something if you hear me, please?
Yeah, we hear you. That's very clear. Thank you.
So we will begin. Anthony, Pont. So we. Yes. Okay. Ok, on va le mettre dans le trou. Je peux y aller pour le mettre dans le trou. Oui, mets-le dans le trou. Mais passe en mode automatique. Because we are sure we hold the pipe to be sure the bits enter in the hole, in the pre-hole. Sorry. Okay, so we are entering in the hole slowly. When we have power. So we have preset the weight on bit of the regulation loop at 215 Newton to be sure to have a security factor of our limits that we have previously calculated. The security factor is about 4 to 5. So there is so it's okay. Okay, Denis, tu peux lâcher, hein, tu sais. Okay. So I will increase the rotation speed. Okay. Okay. So we see we are not yet drilling because the weight on bit is at its minimum point. We have set the RRP of 15 millimeters per minute, and the regulation loop is not yet activated. Okay, so I will start drilling, and now we will be able to go to the target points. Okay, you can hear that we are beginning to drill. I will I activate the regulation loop. Okay.
So you're in an automatic mode now?
Well, I don't hear you because there is a lot of noise here.
Okay. Are you still in manual mode or automatic?
Oh, we are in automatic mode.
Okay, thanks. Does your program have a maximum depth so that you don't drill through the floor?
Of course.
Okay, good.
Can you show us your display where you're getting all your torque measurements and all that?
Can you repeat, please?
The display, can you show us the display where you're getting the measurements?
So actually here it's a old version of the display, but I can show you the new graphs. I just need to click on one button and for you to wait 30 seconds, but it won't stop the drilling process.
Okay.
I can do that if you wish.
Yes, please.
Well, we have, for now, we have a good, okay. We have good data on the drilling process. No. Il faut appuyer sur Start droite. Je passe là. Yeah, we'll show you the display in one moment.
What is the current RPM, revolution speed?
The RPM is at 120 RPM.
Okay.
Okay, now you can see on the display different graphs. Graphs of the RRP, the motor torque, the weight and bits, and the regulation loop coefficients. So yeah, I just made them. I just made this. So don't look at the unity factors. There is a hundredths factor on the weight and bits, and on the P I.
What's happening to the ROP? I saw it increased, then it dropped, and now it is steady.
Yeah, I see that. So RRP is controlled by the regulation loop, and here we can see that we had an increase of weight and bits. So the RRP just dropped.
So if I remember right, you said you have a target ROP that you set, and you're adjusting weight on bit, or weight on bit will automatically adjust to match the ROP, correct?
Can you repeat, please? I didn't understand. There is a lot of noise here.
No problem. So you have a target ROP?
No, I have a target weight and bits. Okay. I will show you the regulation loop. So you can see now on the display that we have the set points weight and bits at 215 newtons. We have the feedback around that value, and the regulation increase or decrease with a scale range of 5 millimeters per minute to the feedback value. To the RRP. So we have a set point RRP, and we will increase or decrease with 5 millimeters per minute, and multiplied by the percentage, by the coefficient of that give me the regulation loop give me, and the output is shown at the regulator table out.
Got it. Thanks.
I will increase the flow. So all the values that we are seeing in the graphs can be registered in our storage in a USB key, and you can use this data. You can take this data and put them in an Excel table to do like a storage of your data, and you can do on this data treatments or data process of the values to get the kind of graphs that you have seen in the presentation of the rig. to see what kind of characteristics the bits in the rock have.
Martin, is everybody on your team an undergraduate or is anybody in a master's program?
Can you repeat, please?
The people on your team, are
Yeah.
they all undergraduates or is anyone in a master's program?
We are all in master's program. We are mechanical engineers specialized in design and production.
Okay, excellent. Thank you.
Mining engineering or geology is not our field. We had the specification at the beginning of the year to create the frame, and we have continued the project to build a rig, a functional rig.
You've done a good job. You've exceeded
Thank you.
other teams in their first year. You've done quite well.
Yeah, this is impressive, guys. Usually something breaks by the time you get to this point, this is really good.
Yeah, you have any commentary on, well, I mean, beyond what you told us about security just a moment ago. So we are we have the s'il te plaît, Kylian, passe-moi ton. Merci. So you can see that with some experimental tests, we have worked. We have done this kind of curve that permits us. It's the weight and bits function of the ARP. No, the ARP function of the weight and bits, and this type of curve can give us an estimation of the parameters that will be used for the drilling process. So that is at 120 RPM. I repeat that we can't go faster because of the bits, not because of the motor. Technically, we could go a lot faster. Maybe the pump is not adapted to our process because it can provide only an amount of 2.5 meters meters squared by seconds. Yeah, it doesn't really have a lot of flow. It's only about 40 liters per second of water. There is no additive in the water. Yeah, you can see in the in the front you can see behind the gear that we have a swivel. It is where the water goes in the pipe. The pipe turns with the bits, and we have been extremely limited by the market and the delivery time all along the year, especially for the motors. So we have sized an ideal system on paper, but we had to adaptate our conception to what was available on the market.
Well, welcome to our world. It's the same for all of us.
Yeah. I suppose it's the same everywhere. On est à 480 mm. On doit aller jusqu'à 55. On va à 8,5 mm par minute. Oui, c'est bien. So here, our regulation loop is more or less constant. It stays at minus 25%. So our advance, our RP is at 10 millimeters per minute. And with the regulation loop influence, we are actually drilling at 8 millimeters per minute. This is to get a weight on bit of I'll check. Yeah, the weight on bit was at 215 newtons. So it's pretty much it respects pretty much the weight on bit that we want to reach. And yeah, we could go with a weight on bit a lot. We could increase the weight on bit that we want to reach, but we don't want to go too fast.
That's okay. There's trade-offs.
Do you remember the buckling limit?
Excuse me?
Do you remember the buckling limit of your drill string?
What limit?
Buckling.
When the pipe fails.
Yeah, we can go to 1,200 Newton. We have reached that weight on bits, but we didn't want to make an experimental test for the critical limit of the drill pipe. Yeah, but actually we have made some calculation during the year. I don't really remember the values, but yeah, we can have a pretty high limits. We can have a pretty high weight on bit on the pipe, but we has the uncertainty of the vibrations. So for us, with our knowledge, it wasn't really possible to calculate exactly where it would reach its critical. Yeah, it's we didn't really know where it could reach its critical buckling because of the vibrations.
Got it. Okay.
So it's more like an experimental test, and it works pretty well until now.
How fast are you drilling now? What's the RP?
8 millimeters, I think.
8 millimeters.
That was what he said a few minutes ago.
j'ai acheté une nouvelle machine à café.
C'est pas les grands, là.
Maintenant, j'ai pris de 120. Non, non, mais elle était à 100, c'est pour ça que je l'ai pris. Et en fait, je prends avec les grosses. Je fais ça comme un déplacement. Je fais les récupérer. Le problème, c'est que si tu dépenses de 150, c'est moins et c'est moins gagné.
You have a sign that shows all of your sponsors. Can you have somebody put a camera on that?
Comment on fait les sponsors? So we have been helped mechanically speaking for all calculations and mechanical material providings by Schaeffler. So the contact with Schaeffler permitted us to have some shortcuts to get more to get faster some material that would take more weeks of delivery time using in Jean-Luc, comment on dit Grand-Duché de Luxembourg en anglais?
Duchy of Luxembourg.
Okay, so using of Grand Duchy of Luxembourg helped us for the electrical cabinets. Yeah, you know Grand Duchy of Luxembourg. It's a limitrof land near Belgium. So they helped us with the electrical cabinets and all the components inside it. Also, it's also permitted us to avoid delivery delays.
Right. Right.
Because they gave us all the materials that they had in stock, or that was how to say, that was obsolete.
Yes.
So with Yozung, the other sponsors are Eaton, which gave us the software to make the display, and Rexworth, Bosch Rexworth, that provided us all electrical components, typically all what is a hardware. So Eaton is like software and Rexworth hardware. Rexworth is also the mark of the motors, the servo motors that we use.
You can contact them if they would like to advertise on our website. Then get in touch. Then get in touch with me. That's Fred.
Yeah. Yeah. Okay.
And we will.
I have the contact of Yozung in this room right now. And if you want, the last sponsor is Diamond, DDS, Diamond Drilling Service, that made us a pretty wonderful bit for us. They studied the bit from Baker Hughes, and they told us how to improve it, and they did it in quite fast and was in a pretty good way. So we are happy to work with them too. And I have made several tests with the bit from Baker Hughes, and but I didn't print it, so I can't show you the comparison of the characteristics between the rock and the tool and the bit.
Okay, we can do that later. Yeah.
If you wish, I can make you in contact right away with my contact with Yozung, who who can give you more information if you need any.
Okay. When people contribute to a team,
Yes.
we consider that a contribution to the program, and
Yes.
we can advertise them on our website.
Okay. Okay. I understand.
Okay.
So it's the website of SPE, the SATs or Drillbotics.
Drillbotics.
Okay.
Ah, mais si, il a coordonné qu'on connaît que c'est.
Ouais, ils m'en ont parlé, ils ont fait genre qu'ils étaient déçus, donc je les avais pas. Mais
Ouais.
là, c'est pas une invitation. Vous connaissez la date? Oui, je crois. Il disait que c'était public. C'est un peu ce que tu veux dire. C'est bien mais bon, je t'avais dit que les revenus sont bien, c'est très bien. Ils ont vu un petit place de sauvage. Je ne sais pas si c'est pas bien, peut-être que va rester une année. Mais 2 mètres, pas de protection. Je ne sais pas si on ne devrait pas. Pas rester sur la fourniture, parce que les Américains, c'est que une action.
Les Américains, les Américains.
Non, ils ont demandé de ce que vous faites. Genre, c'est la première fois que je vous dis software.
Can you show the graph again of your ROP?
Yeah, sure. So. Let me see if yeah, it's okay. It's okay. The RP seems to decrease of a large amounts, but the graphs are regulated in auto scale. So the small variation lets an high visibility on the graph.
Okay, and show the weight on bit.
Well, the weight on bit is yes, I see the monitor, so I see what you see. Yeah, the weight of it also is there is a factor of hundreds. Okay, so you need to multiply the values you see there by hundreds to get the weight on it. It's just a detail. I just made a draft, so it's I forgot to do that, but it's possible to get the data after process.
So the maximum is about 320 newtons.
Yeah. We have regulated to 215 newtons for the weight and bits.
Yeah, but I think I saw a peak of about 320. I think.
Yes, so the weight on bit is calculated from the motor output, the motor for the hoisting system, and with all the vibrations, I guess we can have. I guess the regulation loop can have some difficulties to find a precise regulation. But typically, we will oscillate with a certain we will oscillate around the input data that we give to the program.
Right. But if you put more weight on than 320, you probably will start to buckle the pipe, right?
Yeah, that is realized by experimental tests, and yeah. It's true. We begin.
Oh, yeah.
We begin to get unstable to 800 newtons.
Okay.
We have tested on several works, more soft or more hard, and yeah, we on the hard work, we went to something like 1,200 newtons, and it didn't break. So we are pretty good in the point of view of the safety of this system.
Okay.
We need to investigate further if we want to get more precision on the extreme limits of the pipe. But we need to keep in mind that the pipe is the fuse element to the system, not to break the motors. If something needs to break is the pipe, it's not the motor. So the motors are protected by this tube that is more fragile than.
Right. Right. Well, as you increase the speed of rotation, RPM.
Excuse me.
Excuse me. If you increase the RPM, the speed of rotation,
yes.
and you increase the weight on bit,
yes.
you also need to look at fatigue. SN. Number of rotations times the force. So that pipe may work okay during your test, but after so many rotations, it may fail.
Yeah. Okay. Yeah. I understand.
Okay.
I understand. We
So
didn't think about this aspect because we are not able to cover 100%.
Yeah. Consider that next year. Consider the SN curve.
Okay.
But that's good. I've seen a very stable system. I think you're doing well. I don't need to see any more of this unless you got something that you would like to continue. We could switch back over to the other team.
Okay. So we are on the same grid. So we use the same power source to power supply our systems, and well, we haven't made a hole that deep before. We just wanted to see the opportunity. We had the work. We had the work yesterday, so we haven't had the opportunity to make a hole that deep previously. And we just wanted to know if there weren't any other aspects that we didn't wait, but I think we are good. We only need to drill for about 200 millimeters. So the process is in more than 15% complete. We could wait, or we could stop the process with your authorization and to pass to the other team if they are ready.
If they're ready, then we'll make the change. You can ask them. The thing that you will see in the future, if you increase the rotation, if you increase RPM, you'll see vibrations, and the vibrations will affect the pipe and the coupling and the bit. And there's some things that occur in the real world of drilling where the vibrations are a big concern. And,
I know that. Yeah, sure.
And there's a term called mechanical specific energy.
Yeah.
And that's something you can look at in the future.
Okay, it's noted. Thank you. I will ask.
We'll put our comments in writing to you.
Excuse me, can you repeat, please? There was a lot of noise here.
Yeah, we will write down our comments so that you have them in writing, not just what we're saying out loud.
You will send it by email.
Yes.
Okay.
Next week.
No problem. Yes. Okay. You want me to go ask to the other team if they are ready?
Yes, please. Shashi, this is probably the best first year effort I've seen.
I agree, man. This is fantastic. They're able to drill. They have a control loop that works. So good job, team. Actually, great job. This is really good.
Oh, so okay, they are ready. Do you have any more questions of the process for now?
I don't. No, I think you're doing fine.
So we will terminate our process, and I will put the microphone next to the other team so you can talk to them. Okay.
Thank you, Martin.
Thank you.
Hey, would you, Enrique, you want to stop this and then restart a next recording?